Hi, I'm Rick Crosslin, and today we're going to do some kitchen chemistry. All the things you see here you could probably find in the kitchen, with the exception of a balloon. We're going to talk about physical changes and chemical changes. Those are two types of chemistry changes you need to know about. So here's a piece of paper. When I crumble this paper or wad it up, that's a physical change. It's still paper. Even if I tear it, it's still paper because I haven't done anything to the material. I haven't changed the material. That is a physical change. When things melt, when ice melts or water boils, those are physical changes. Now, a chemical change is when the material changes. For example, when you cook food or you digest food or a fireworks, or you might see right here this candle I'm going to light up right here. This candle, now what you're seeing right here is this is a chemical change because that candle, the burning, is no longer going to be wax and a wick. It's changing into something new. So today we're going to do a couple lessons and a couple activities that you can do to learn more about chemical changes. Let's take a look at some powder. And the powder I have right here is baking soda. I'm going to put a little bit of baking soda right here so you can see it. And this baking soda, I could mix it with some rice and that would be a mixture and we could separate it. Let me get my pipette, and so if I use my pipette right here, I'm going to see if I can put some, I think this is water. Let's find out. I'm going to put a little bit right here on here and we'll see what kind of change, if any, do we see right there. Nothing. See, a chemical change, we're looking for three things. It either can be a temperature change, a color change, or a gas is formed. Let's see what happens if I add vinegar to baking soda. Let's see if we can get a temperature change, a color change, or maybe a gas formed. Here we go, ready? Vinegar. Yeah, I can waft that vinegar and look at that. When I add vinegar to it, we're definitely making a gas. In fact, that gas is carbon dioxide, and I might be able to put that flame out with carbon dioxide, but we'll get that in just a second. So that's a pretty cool experiment you can do and have some fun adding, and you see a reaction on the baking soda and the vinegar. Let's take it one step further. Let's try putting some in a baggie, and let's see if we can actually see a gas being formed. So I'm going to add some baking soda, 3 or 4 spoons into this baggie right here, and I go 1, 2, 3, maybe 4. And now you got to be quick about this. So I got my baking soda, and it's a Ziploc bag. You see the baking soda right there, and I'm going to add a bunch of vinegar all at once, and I'm going to seal it. Let me practice sealing. Pour, zip, pour, zip. If you have someone to help you, this would be a good 2-person project. Put my thing. Here we go. Ready? Here comes my vinegar. I'm going to pour, and then I'm going to zip it locked real quick. Here we go. We'll see if a gas is made. Ready? Pour and zip. And look at that. In fact, it got bigger and bigger and bigger. There's a chemical reaction. And you can feel it, a little bit of a temperature change. Now, all of that gas that just filled up like a pillow is carbon dioxide. In fact, let's see if we can do that. Let's see if we can put out this, here we go. Let's see if I can put out this candle just with carbon dioxide gas. So there we go, it's burning. There we go. And I'm going to slowly open this and we'll see I'm not going to blow it out. I'm going to let the carbon dioxide gas go down and see what happens. Open it a little bit better and pour it over the side. It went out. Got a little bit of water on the side, but the CO2 put out the flame. I want to try one more. Now this one has to do with an antacid, for example, like, let me move this down here so you can see it, an antacid like Alka-Seltzer. And if I put an Alka-Seltzer there, right where you can see it on here, I hope, if I put some water on it, it should bubble up and make some nice CO2 in your belly. There we go. But the thing about Alka-Seltzer, it's better if you break it up because chemical changes do much better if they have more surface area. So here I was just holding this one Alka-Seltzer. I was just holding this one Alka-Seltzer, but if I break it up, like I've done right here to this one, if I break it up, now there's a lot more surface area to be exposed, and it should be a lot quicker. Let's find out if it's quicker. So that one's broken up, and I'll do a squirt of water on the Alka-Seltzer. And because there's more surface area, it's a quicker reaction. Which brings me to my last one. What I did was I blew up a balloon, I broke up some Alka-Seltzer, and I put the Alka-Seltzer inside of this balloon right here. And I've got some water here. So all you need to do is lift it up, and maybe we'll make a gas, and maybe we can get this balloon to inflate. Let's find out. Here we go. Ready? Kitchen chemistry. It's all about chemical changes. Let's here and lift it up, and look up. There we go. It's starting to grow more and more as you see the reaction going on right here. Chemistry. It's all about surface area and reactions. Hey, have some fun. Kitchen chemistry. Chemical changes. It makes a gas, it changes color, or it produces a temperature change. See you next time.